These notes are on simplifying square root expressions. Up until now, we've dealt with simplifying square roots where the quantity underneath the square root was a number. And now we're going to start dealing with simplifying square roots where the quantity underneath is a variable. So we can write the square root of x squared as the square root of x quantity squared. And since we can't take the square root of a negative number, we have to make sure that I specify that this answer of x, when I'm saying the square root of x quantity squared, simplifying to x, is positive. And the way that we say that it is positive is by using absolute value. So let's look at a few examples. Our first example, the square root of 16 times the square root of 16a squared. So I can break this up into the square root of 16 and the square root of a squared. Now the square root of 16 is a number that we are familiar with. 16 is a perfect square, and so I can rewrite the square root of 16 as 4. Now the square root of a squared, I want to make sure that I take care of the fact that if a is negative, there are some trouble. So I need to make sure that the square root of a squared, which also equals the square root of a squared, that means that this a can only be positive. However, nothing in the example tells me that. I'm not told that a is positive. So when I simplify the square root of a squared to be a, I need to somehow indicate that I understand that a must be a positive number. Well, they don't tell me if a is positive or negative, so in order to make sure that it is positive, I use the symbol absolute value. Example 2. Example 2 follows the same sort of logic. However, in this case, we don't have a whole number underneath the square root. We have a quantity that is being squared. So if you can imagine, if I sort of cover this up, I have the same pattern here as the square root of something being squared as I did up here. The catch being, of course, that instead of it being one letter, it is an expression. It is a binomial. So I can simplify this as x plus 4. But again, because I can write this as the square root of x plus 4 squared, I need to indicate that this quantity of x plus 4 can only be positive. And since the problem doesn't tell me it's positive, the way to ensure that it becomes positive is to put absolute value around the expression.